Welcome back to our series on Kubernetes for beginners. In the last video, we had discussed about pods and how we can create it. Suppose you want to create 4 pods for your application. How will you do it? You may apply the pod definition file 4 times to create the pods manually, but now what if one pod terminates or gets down? In that case, you have to again create another pod manually. Well, that's a lot of manual work and we definitely don't want to do it. So, what is the solution to this problem? Well, if you are looking to ensure your application is always running smoothly, you have come to the right place. Today, we are diving into Kubernetes replica sets. We will understand their definition, their benefits, and how we can create and manage them using YAML files and command line tool. So, what exactly is a replica set? A replica set is a Kubernetes resource that ensures a specified number of pods are always running at any given time. It's like having a manager that makes sure a certain number of workers are always present on the job. Consider a pizza shop which delivers pizza across the town. Also, consider that the pizza delivery boys are like pods. The manager looks in the board that says we need 3 delivery boy on shift. It's like representing the desired state of replica set. Now, one of the delivery boy leaves the shop for some reason. It's like one pod fails because of some error. The number of delivery boys goes down to 2. The manager immediately notices that there are only 2 delivery boys available instead of 3, and in this scenario, manager quickly hires a new delivery boy to ensure there are always 3 boys on shift. This represents the replica set creating a new pod to maintain the desired number of replicas. Now consider that we are getting more than the usual orders, so we need more delivery boys. The manager updates the board to say we need 5 delivery boy on shift. So more delivery boys or the pods are added to the team to meet the new demand. This represents a scaling up scenario in Kubernetes. Later, when things slow down, the manager changes the board back to 3 delivery boy on shift. Some delivery boy leave, representing scaling down to adjust the new desired state. So manager of the pizza shop is now satisfied as the right number of delivery boys are always available, just like how a replica set ensures that the correct number of ports are always up and running. But why to use a replica set? Let's break down its key benefits. First one is self-healing. If a pod is deleted or terminated, the replica set automatically creates a new one to maintain the desired number of replicas. Second, scaling. You can easily scale your application up or down by adjusting the number of replicas in the replica set configuration. Third is workload distribution. Replica set ensures that workloads are distributed across multiple ports, enhancing reliability and availability. Let's get into how a replica set works behind the scenes. A replica set uses a selector to identify which ports it should manage. The selector is a set of labels that match specific ports. Whenever there is a mismatch between the desired state, that is the number of replicas, and the actual state, the replica set takes action. For example, if a port is deleted, the replica set detects the discrepancy. Suppose we have a replica set of around 5, that means we need 5 ports at any given point of time. And now one is deleted or terminated, the replica set will take an action and will launch a new pod to match the desired count. Now let's create a replica set step by step. We will write a YAML file that defines our replica set. First, open your code editor and start a new YAML file named replicaset.yaml. As usual, first we have API version, kind, metadata and spec. For simplicity of understanding, let's open port definition file on the other side. Okay, so the API version is a bit different here. It is apps then v1, whereas in ports it was just v1. So we have to take care of this thing. We can get the exit API version from the official Kubernetes site. The kind would be replica set as we are creating a replica set. In metadata, we can add name and labels. So we will add a name like example rs or any custom name. Okay, now let's define the specification for our replica set. So spec will comprise of three parts: replicas, selector, and template. Okay, so in template part, we define the pod definition as we did while creating pod. So I'm going to copy contents over from the pod definition file. So everything under the metadata and spec of the pods are copied. For now, let's not get into details of this, but we'll see in detail in later part of this video. Okay, replica set also requires a selector definition. This is a mandatory field. The selector helps the replica set identify what pods fall under it. But why would you have to specify what pods fall under it if you have provided the contents of the pod definition file itself in the template? It's because replica set can also manage pods that were not created as part of the replica set creation. Say for example, there were pods created before the creation of replica set that matches the labels specified in the selector. The replica set will also take those pods into consideration while creating the replicas. For example, like we are creating the ngNX pod and we already have two ngNX pods in the system with the label ngNX. Now, if we create a replica of like 5 and 2 are already there, then replica set will create 3 new pods instead of 5. Match label selector simply matches the labels specified under it to the labels on the pods. So this label and the match label selector is the same value, like in the pods if it's nginx, here it will be nginx. If it's front end, it will be front end. Also, we need to define how many replicas we want for a pod. So we include a property replicas and we provide a number like 3, 5, 7 or something. We can also have one, and that will ensure like that the one pod is always running. So okay, so this is how our definition file will look like. I understand that you might have a questions about why do we use selector and template. We will discuss about it in our later part of this video. For now, let's apply this replica set using kubectl apply command. This is similar to how we applied pod definition file. Open the terminal and type kubectl apply, then the f and the file name. This command tells Kubernetes to create a replica set based on our YAML definition file. Once applied, let's verify it if our replica set is running as expected. So we type kubectl get replica sets. As we can see, the example rs replica set with the desired, current and ready replicas are set to 3. This confirms that our replica set is managing 3 ports as defined. Now let's see how many ports are created. Type kubectl get ports, and now you can see we have 3 ports created by the replica set. Now let's scale our replica set. So we want to increase our port count to 5. It's as simple as modifying the replicas count. So we can edit the YAML file and set the replicas to 5 and then reapply the kubectl apply f command to apply the new replica set count. So let's run a command to get list of all ports, and we got 5 ports now. Okay, but it's not always necessary and it's not very convenient to edit the replica definition file just for a simple chain. Instead, we can make use of a single line or a one-liner command like this: kubectl scale replica set and then the name of the replica set. In our case, it will be example rs and hyphen hyphen replicas equals to 5 or 7 or whatever value you like, and click enter. This command directly tells Kubernetes to scale our replica set to the given value. When you no longer need the replica set, you can delete it with a simple command, that is kubectl delete replica set example and rs, or the any name of the replica set that you want to delete. This deletes the replica set and all associated ports. We can verify it using kubectl get ports, and now we can see that the ports created by the replica set is also deleted. We can also use rs as a alias for replica set. So instead of kubectl get replica set, we can simply type kubectl get rs, and that will give the exact results. Here are a few best practices when working with replica sets. Use labels wisely. Ensure your labels are unique to avoid unintended port management. That means if you want to get replica set for front-end ports, make sure that the label is front-end. Then monitor resource uses. Keep an eye on the resources consumed by our ports to ensure optimal performance. So we had seen like these ports will be created on the node with storage and network and all other things. So we have to monitor the amount of resources these ports are using. Then leverage the auto scaling. Use the horizontal port auto scaler for dynamic scaling based on real-time metrics. We will look more into it, but understand like that suppose we have a heavy load, then it should automatically scale, and when the load is less, it will automatically decrease the count of ports. For me, also labels and selectors were confusing at first, so it is necessary to understand them as they will be used in other resources as well. So let's break it down in simple terms. Imagine you have a web application that has hundreds of ports. You don't really care about any other port, but you want to make sure that there are always three copies or instances of the front-end port running. So if one port goes down, another one can replace it without any manual effort. In that scenario, we use labels to identify our ports. Think of labels as name tags you put on your pod in Kubernetes. When you create a container for the front end, you give it a label that's a front end. When you create one for the back end, you give it a label that says back end. So that means we have a front end pod, we have a back end pod. If we are creating a web application which has three pods, okay, all these three applications are part of front end. So we will label them as front end. Okay, so it was like grouping them and giving it a name. These labels help Kubernetes know like which pod is which. Now you can set up replica set with selectors. To make sure there are always three front-end pods running, you use a replica set. The replica set job is to keep an eye on the pods with a specific label. In this case, the ones labeled app equals to front end. Selector. The replica set uses selector to look for ports with the label app equals to front end. This means it's watching all the ports that are identified as front end. Then you define the desired number of ports. This means that you tell the replica set that you want three front end ports, and you use the property replicas for that. How it works? First is it will monitor it. The replica set constantly check to see how many ports with the app equals to front end label are running. Then maintaining the count. If one of the front end ports crashes or gets deleted, the replica set notices that there are now fewer than three ports. It will then automatically create a new port to replace the missing one. And it will also help you in scaling up or down. If you decide you want more front-end ports, you just tell the replica set to maintain say 5 instead of 3 replicas. It will then create 2 more ports to match the new desired count. So labels are like tags that help identify and group your ports, and selectors are the way replica sets find and manage the ports based on those tags. So labels will be at the pod level. Selector will be at the replica set level. The systems helps ensure that the right number of a specific type of pods are always running, keeping your application stable and responsive. Okay, that's it on our video on Kubernetes replica sets. With this knowledge, you can ensure your application are resilient, scalable, and always running smoothly. Don't forget to like, share, and subscribe for more Kubernetes content. See you in the next video.